Dear students, let us continue our learning on the course Data Structures and the Applications. We are in the 7th session, part 2, wherein the last topic, the amazing problem. So we are not able to cover in the last video, which we are covering in this session. That is the topic is the amazing problem. So myself, Dr. Suresha D from the Department of Computer Science Engineering from Canara Engineering College, Bantwal, Mangaluru. So to start with, amazing problem. So the amazing problem, these checkerboard boxes you might have seen during your school days of playing. I hope so. So wherein we need to mark the route from the start point to the end point. So for discovering the routes, so we used many methods over there if you remember. So what we have done there as I remember is we start from one path, and if that won't path lead us, if it won't lead us to the destination, we will travel back, means we will go back and we take the alternate path and we try to find the route over there. So that is somewhat similar to that of your box. If I take up this as the box, then we will start over here, and from here I need to exit. So this will be my start point, and here I need to exit from here. This will be my start point, and this will be my exit point. Or you might have seen a game wherein you need to find the route such that the rat or some animal will find the route for the food. Fine. So such a problem is your amazing problem. That is, we used to have a start and the destination point, and in between that one we will have many hurdles over there. If we are not able to get a route from there, we need to go back and we need to take the alternate path. Means before proceeding, we should save our previous status. That is the location where we are in. Then we have to continue. Fine. So that is to sort out this problem, the stacks are used. So where in the recent visited one, whenever we visit any box, your what we call coordinate values, those coordinate values will be stored onto the stack. And if we won't get the route from the next point, then we will take back our previous route, and we are going to have the alternate path search from that location. So if you remember your stack application, the stack application says that it's in last in first out data structure, means the last two in is the first two out. Right? So now let us take the stack and let me try to solve this problem over here, which is there on the right side. So now if you observe over here, so now this is my entrance point. From here I need to make the entrance, and from here I need to make the exit. I need to take the path through zeros only. Ones are the hurdles over here. Ones are my hurdles over here, and I need to take the path only from the zeros. I need to take the path only from the zeros over there. Fine. So for selecting that path, how the path can be done? Let me try it out over here. First, I can make the movement in the horizontal direction, or I can make the movement in the vertical direction, or I can make the movement in the your diagonal directions. All the routes are possible. So to make the route such that it won't go out of my end point, we can put the hurdles at the end over there. So that I won't, so one indicates the hurdle, I can't cross. So I can put the hurdles all along your end points over there. Whatever your end points are there, you can put your hurdles over there. So now these are the hurdles for the top row. These are the hurdles for the your right end, and in the same way we can have the hurdles for your bottom row, and the bottom left column. So you can have the hurdles in all the four directions so that our tracing won't cross the limits, won't cross the our boundary over there. Fine. Then next, once we have created the hurdles on the all the sides, then next if I try it out, so first we can make the first movement in the diagonal direction. Let me take the try the first part. Then I will take my route over here. Then I can take my route here. Then I can take my route here. But here there is a hurdle on all the three sides, so this is not possible. So once it is not possible, I will go back here. So this is the same path. This is the same path what I have tried. So now again the next route is not possible. I will go down. Then next again I will go down. Then next I can take this path. So next this path. Next this path. Next this path. Next I can take this path. This one. Then this one. Next this one. Then next I can take this diagonal path, then this path, then this horizontal path, vertical path, then the diagonal path, horizontal path, diagonal path, vertical path, vertical path, then the horizontal path, diagonal path, horizontal path, horizontal path, horizontal path, horizontal. Then I can come here, I can come here and I can exit. So this is the route. So this route we need to find for the this route I need to find for my problem. So for finding that one, so if you remember, once I reached here, I was not able to go next. Once I am not able to go next, what I have done is the previous location where I visited, this one. To this location, I stored in my stack. That is last to in. The last location I stored in my path, and I will try to take the alternate path over there. I try to take the, this was the path which was I took earlier. Then I try to take the alternate path. So now if alternate path leads to my exit, it's fine, or else I will go for taking my alternate path. Fine. So now I need to solve this problem. That is nothing but a rat searching for a food, finding the path for it, or the what I told in our childhood life, the game what we played. That problem we stated as the amazing problem. That is your amazing problem. Fine. So now let us go for implementing. For the implementation of the amazing problem, so we have the different movement possibilities which are possible. The movement possibilities may be your horizontal direction, which we can move towards the left or the right, or we can have the vertical direction, that is either I can move to the top or the bottom, or I can have the diagonal directions, that is I have the two diagonals over here, so which is giving me the four paths over there, which is giving the four paths over there. So now if I go with my index values over here, if at all I go with the index values, now if I represent this one in my coordinate system, suppose I have the point called 2 comma 3, if you assume, then the surrounding points will be, if I go here, if I go here, then here, then I can go over here, then I can go over here, then the diagonal points here, 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 and the here. Fine. So this is our normal coordinate system. Fine. But when you go to your computer science course, so here we work on the fourth quadrant system over there. We work on, this is your first quadrant system. If you remember, this is our first quadrant system. This will be my second quadrant system. This is my third quadrant system. And this is my fourth quadrant system. But what we actually practice is our first quadrant system. But what we actually practically use in our mission will be our fourth quadrant system. That is the top left will be taken as our origin. This is our origin point. Right? So now if I represent my 2, 3 here, then the surrounding points will be your 8 surrounding points will be your marked. I have marked a cross mark over there just to represent the surrounding point, which will depict me the direction, which will give me the direction over there. So now this one will be, if I go for numbering this one, my coordinate values, this is 0, this is 1, 2, and the 3. In the same way, this will be your, so this is my 1 if I take up, this will be my 2, sorry I went wrong over here, let me go for the index value here. This will be 1, this is 2, this is 3, and this is 4. So this is 0, then this is 1, this is 2, and this is 3. So this will be your x-axis, this is your y-axis, right? So now if I go for this value, the index values for this one will be 1, 2, right? Then if I go with this one, this is your 2, 2. Then this will be your, so this is 1, this is your 1, 2. This is your 2, 2. Then this will be your 3, 2. So then next this will be your 1, 3. Then 2, 3, 3, 3. So next if you go on, this is a 4, 1. Sorry, 4, 2 it is. Oh, this is 1, 2. This is a 1, 3. This is your row is 1, column is 4, 1, 4. This is your 2, 4. This is your 3, 4. So if I generalize this one, so if it is I comma j, then this is I minus 1 comma j minus 1. This is I minus 1 comma j, I minus 1 comma j plus 1. This is I comma j minus 1, I comma j plus 1. So this is I plus 1 comma j minus 1, I plus 1 comma j, and I plus 1 comma j plus 1. So these will be your index values. Fine. So now if I go for representing with the directions, I am using the total 8 direction which are represented by 0 to 7. I am using total 8 directions which are represented by 0 to 7. The moment, the north moment, to have the north moment, vertical is subtracted by 1, but the horizontal will be retained same. So that will be your north direction. Vertical was your 3, 3 minus 2, sorry, 3 minus 1, which will be equal to 2. The same thing we are doing. Northeast. So for the northeast direction, so what we are doing? So this will be my northeast direction. So what I am doing over here, the vertical is subtracted by 1, but the horizontal one, 2 to 3 I am making, that is incremented by 1. That is my northeast. For the east movement, so now if you go with your east movement over there, fine. So now if you take your east movement, so your vertical is remains the same, 3, 3, it remains the same, but your horizontal increased from 2 to 3. That is, your vertical will be retained 0, but the horizontal is incremented by 1. So in the same way, how we have done over here, in the same way, your total 8 directions are marked. Total 8 directions are marked over here. So that is for your horizontal and the vertical movement. These offset values are represented as a structure over here with the vertical and the horizontal as your integer values. And for each point, we have the 8 different offset may be present. For each point, there may be 8 different neighboring values will be there that will be present over there. That is, offsets will be movement of 8 over there. Right? So now, if you continue, once you are clear with the directions and continue with the actual problem. So now to find the next row, the equation what we follow is next row will be equal to row plus your direction. So your movement direction and the your vertical value. Fine. So that movement direction can be one of the any 8 directions what we have. Then next will be in the same way it is for the column. So now if I go for each element, now I have associated with the 3 components over there. First one will be your row component, second one will be your column component, then next will be your direction component. Now each element will have the 3 components which are present over here. Now if you go for your actual implementation part, so it is implemented as a stack. I told it's an application of stack. So while stack not empty means if you have any such possibilities over there. So now while stack not empty, so we take the topmost one. Topmost one will give us the recent visited point. Topmost one will give us the recent visited point that we take out from the stack. From there, we check whether any movements are possible from the current location. How to check that one? In all the 8 directions, I will check whether I have any coordinate with a value of 0. 0, as I told, that will give me the route. That will give me the route. I will take that one. Is there any movement from the current position? If you have any such movement over there, then I will take those index as a next row and the next column, the coordinates for the next row and next moment. Then the direction I will mark. I told 8 direction: north, south, east, west, northeast, northwest, southeast, and the southwest. Total 8 direction. Then I will mark my direction over there. And I will check whether I reached the end. How to check? If my next row is my exit row and if my next column is exit column, then I will give the success over there. If not, then I need to decide my next moment over there. How to decide the next moment? If my next row, next column equal to 0, next row, next column equal to 0. So now if it is my case, then I will mark it as 1, stating that I have visited that one, no need to visit further. Then I will add that one to my stack. Then I will add that one to my stack. Means if the next route is not possible, I will come back to that same location and I will take the alternate path. I will take the alternate path. Then I will mark the rows and the columns. So the row will be equal to next row and column will be equal to next column and the direction I am going to mark. In the same way, I will track for the all the possible 8 directions. All the possible 8 directions I will track on. Fine. If you go for your actual path implementation over here, so now if you start with the mark 1 comma 1, this is my starting point. So I will mark it as 1, stating that first point. Then top will be equal to 0. That value I will put it to the stack. Row equal to 1, column equal to 1, and the stack direction also equal to 1. I will start from the first direction. So now how long I need to do? I need till that stack becomes empty. No more routes are possible. Means no, I don't have the routes at all. Or if I have the root, then the found will I am making it as a 1 if these two conditions. As long as these any one of these conditions satisfies, I will quit. After quitting, I will check. If found means if I end in my final path, then I will say that I am success and I will give my path over there, or else I will give the message that the maze does not have the solution. Right? So now in my main path, I will take the recently saved one. I will take the row and the column value. Total 8 directions are there. So while direction less than 8 and not found, I will try to get the next row and the next column. And I will check whether it is an exit row and the exit column. If found, then I will put the message true. If I have not found, then I will check the next row, next column value is 0. 0 complement of 0 is 1. If I found 1, 0 means I have the next option is possible. If it is the case, then I will say may mark them as 1 and I will mark the row and the column value over here. To which row, which column. Then I will find the direction. Then I will find the direction, which direction I need to move. Then I will push my position. That is what the position. I will push the row, column and the direction I am going to push. And the new row and the column values I will set and I will proceed. And I will proceed with the while loop. Right? So that is, it is a simple application of the stack to find the root over there. And the amazing problems work on the concept of your stack. Fine. So I hope it is clear. The references for these sessions are from the textbook Fundamentals of Data Structures in C, second edition, written by the Sartaj Sahani and Elisa Orovis, and data structures from the Sham outline series. Thank you.